Yes, now recording. So you rank them accordingly. For example, if you look at these distances, we have 73,000, 73,280, 38,200, 1050. And that might be the biggest distance, 171,050, 89, 174, 113, 372, 129,040, all the way up to 9,000, 651. So you are going to consider the smallest distance. Uh, the smallest distance there will be, if we look at that, 64, 16, that is 694, 38, 200. So when you go back there, 20, that is the second one, senior. So the nearest neighbor, when k is equals to 1, that is why the rank of k is equals to 1. When k is equals to 1, the k nearest neighbor will actually predict that this guy will be a senior employee. But what about when k is equals to 2? So we look at the, uh-huh, here we are. Yes, rank. It is called rank. Rank as far as, yeah, rank as far as distance is concerned. So let's just say the lowest distance, Euclidean distance. So, and so it is actually optimized when hyper-tuned, hyperparameter tuning. It is actually optimized when you increase the value of k. So let us try and increase the value of k and see. At k is equals to 2, yes, when k is equals to 1, we've seen that that is senior. So let's see k is equals to 2. So the smallest distance of the 38 200, that's going to be, is it the 78 one, 73 one? 73. So let's look at 73. So that has been into junior. So for now, we just have senior and junior when k is equals to 2. In this case, use the value when k is equals to 1. Yeah, the same thing. The third one, when you move to the third one after 73, let's say we have 70 something again, 80, is it 89? Yeah, so that's the fourth place. And the fourth place is mid-level. So when such a thing happens, we still use senior. K is equals to 3, 99, that is second last one, mid-level, higher. When you reach this case now, k is equals to 4, this k is equals to 4, you now choose the model one, the one that appeared the most. That's what the sentence meant. So the employee rank that appeared the most was mid-level because it has appeared twice, while junior appeared once, senior appeared once. So when k is equals to 4, this employee will probably be a mid-level employee. And then we can confidently say that because the value of k has been increased. I mean, we have tuned the hyperparameter accordingly. Are we together? Okay. So that's how it's done. So let's see. And of course, what we also do in machine learning to ensure that you get the concept clearly, you also try and calculate the accuracy, predicted versus predicted versus actual. You calculate the accuracy, then you also calculate against k, then plot it in a line graph so that you see when the value of k is highest and when the accuracy is highest. That is the value of k that you choose. We are going to see that when building the machine learning model. And again, like we said, using a for loop, you can also try and find the best match for k. That is especially, it comes immediately before you draw the line graph, so that you just map the value of accuracy against k, so that you can see which k produces the best accuracy. You're going to also use for loop for that. So when it comes to this, it's always straightforward. And like I said, you can also use it to classify or to regress. So we are going to see how it is used for regression. So the following will be imported: pandas, numpy, matplotlib, and seaborn. So we are also going to see actual versus predicted. That is why we are importing seaborn for scatter plot. Then pie plot is going to help us draw a line graph. Then trend and split, of course. Yes, yes. Mm-hmm. Yes. Uh, uh, no, no. I thought you were continuing with the question. Uh-uh. I thought, I thought you were continuing with the question. No, 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 no. What happens is that you look at the model when k is equals to n. Sorry, I broke some down sometime. I said when you have k is equals to n, consider the categories under n. For example, k is equals to 4. Consider the categories under those four values of k. The model category, that is the category that appeared the most, is the one that we settled for. For example, now, in our case, we can say k is equals to 4 is the best nearest neighbor classifier that can be used to rank. So k is equals to 1 is going to mislead us. K is equals to 2 is going to mislead us. K is equals to 3 is going to mislead us because the three are producing this distinct results. But when we moved to k is equals to 4, we realized that there were some models. Mid-level appeared twice. So we are confident that with k is equals to 4, the four nearest neighbors, two of them are actually from the same. So are we together? Yes, yes, definitely. Okay. And so standard scale, of course, right now I do not need to explain what trend split does, and it is imported from model selection. Also standard scalar. But now from when it comes to k nearest neighbors, just go and search on sklearn.neighbors. You will find k nearest neighbors classifier and k nearest neighbor regressor. Then metrics, we have accuracy score, precision score, recall score, F1 score, and rock AUC curve, then confusion matrix. Then lastly, for regression, we are going to look at R squared and mean squared error. So let's see. We import our table, look at the first, we have first 5 rows and 21 columns. This is the table the Chan table. So our main focus, you should know the main focus before you start building a model. In this case, we want to find the nearest neighbor classifier. So maybe we just want to prepare data for KNN classifier to predict the Chan. So we want to see which one will actually have people exiting our company. So having known that y variable is the Chan, the Chan is the y variable, the outcome or the response variable. Then the others most probably will become the x variables, which are the independent variables. So we want to calculate the distance between each and every variable to the Chan variable here. So for us to do that, it means that we must scale this data first. Is when we can do the calculations. Remember that Euclidean distance calculations depend on numerical values, but here we also have some non-numerical values, month to month, 1 year, month to month, 1 year. You see all of these, like paperless billing. So this one cannot help us. So what do? We first of all we first of all do one hot encoding. That is the feature engineering thing I talked about. Then after that, we scale the values. Then after scaling is when we calculate the distance or implement KNN classifier. Of course, sklearn has done lots of the work for us. Our work is just to reuse their codes. So some pre-processing, remember when we type df.info, sometimes back we understood that total charges were objects, so we must change them to numeric. Then also we fill the null values with median. Then we drop the custom ID because we did not need it. Then we selected the categorical features and change them to lists. Then also we remove the chan from the categorical features. Then we got the dummies of the categorical features. So this is just a repetition of what we did in logistic regression. And last, this is what it is called one hot encoding. Then lastly, we say that we mapped the F-chan accordingly. So yes is 1 and no is 0. Having done that, we prepare data for now KNN classifier. Remember, if you don't do this, you will get a very, very wrong prediction or wrong results. So you must ensure that you do this. Please ensure that you do this. So that is pre-processing. Then next, we also went ahead and dropped the chan. Of course, you know why we did that, because now X class. Then we split the dataset into 28 as needed, and we use the reproducibility seed of 42. So this is when we can now be confident that we've cleaned our dataset, and we should now continue with implementing KNN. And I said, since this is distance based, so scaling is critical. If you don't do that, expect wrong results. Because this is distance based, meaning it calculates distances based on numerical features. But most of our features here are not numerical, they are categorical or discrete. So you must do that. And scalar class, we've called our standard scalar class. In some models you just find it being called scalar. So this one is your name, your preferred name. But ensure you read and know what the standard scalar does. It's basically the standard scaling that we talked about in statistics for data science. So it's going to transform the X train class. Of course, the X train class, what did we do? We split it into 80-20. And also transform the X test class. Once we did that, we can now go ahead and find the best range of values that can be used to fit our k-nearest neighbor model. In this one, we've used range 1 to 21. You can also go ahead and use range 1 to 51. There is no problem. Remember, in Python, when you say range 1 to 21, it's going to count from 1 to 20, and you know why. Yeah. Then we also have, so the k values are range 1 to 21, meaning 1, 2, 3 up to 20. Then the accuracy score is an empty list. So you know what you are going to do. We are going to use a for loop to calculate the accuracy and append it to the list until we find the accuracy score for all the 20 values. So for k in k values, so it means for a number in the range of 1 to 21, 1 to 20, sorry. Okay, range of 1 to 21, that is basically means the number 1 to 20. The KNN classifier model, you just call the k nearest neighbors classifier with the number of neighbors is equals to k. The very main argument here is the k neighbors, n underscore neighbors. And if you come to the documentation, it's always there and explained. The n neighbors is the number of k that you want to work with. So this is hyperparameter tuning. You are the one to ensure that you use the best hyperparameters. I mean, the best value of k that's going to produce the result that you need. So when we go to classification, k nearest neighbor, and here it is. And the k neighbors classifier. There are others, but the most commonly used is k neighbors classifier. So number of neighbors, as you can see, the default is 5. the number of neighbors to use by default for k neighbors query. That is the number of nearest values that might be used to accurately predict the category of the value in question. In our case, we were trying to predict the job group of a person who is going to earn 200,000, and we've actually used found out that k is equals to 4 gave us that this guy is gonna be in the category of mid level. So that's the n neighbors. We also have weight function using prediction, possible values, uniform weights. All points in each neighbor are weighted equally, meaning the points are treated as independent and as equal to each other. And I think that is basically the default. Yeah, that must be the default. Distance, weight points by the inverse of their distance. In this case, closer neighbors of a query point will have a greater influence than neighbors which are further away. So, like I said before, if you're not sure of who is this now? Hello. Yes. Poa sana, si nikupige baadaye, niko kazi. Sorry, can you hear me? Okay. So, when you are not sure of what these arguments are, please just leave the default, especially the n neighbors. If you're not sure, leave the default. But if you know what you are doing, for us, we know what you are doing. We are tuning the hyperparameters. Please continue to do that, and that's exactly what you want to do. For example, if we leave it as n neighbors is equals to 5, maybe at n neighbors is equals to 5 was not the best parameter. So we are going to get the wrong results. And that's why in our case, we are tuning the hyperparameters. So let's continue with tuning the hyperparameters. Then after that, you fit the model with the X train class scaled and Y train class. Then after that, you predict with X test scaled. Then you append the accuracy score based on the Y test class and Y prediction. Is there anything I need to explain in this for loop? Yeah, it is actually it's very much direct. And when we do that, now let's remember now for each and every for one, we said n neighbors is equals to k, but k ranges from 1 to 20. Because we said for k in k values. So in Manisha, the for loop will iterate. When k is equals to 1, we append the value of accuracy score once we fitted the model and predicted. K is equals to 2 until we now find 1 to 20 with the respective value of k's. And then we can now predict, plot pt.figure, pt.plot k values against the accuracy scores. And we are marking it with just a dot ndio hiyo hapo. Hata marker ukiweka x, it will change to x. But the best one is dot, so don't use x. But I think if the marker of x does not exist, it's also not going to pick. So you can use the x, there is no problem. You can use dot. Now the title, I think we talked about the title, the y-x label and the y label. And if you want it to be gridded, plt.grid is true. This is the grid that you can see 0.8 and whatever. Then the figure can be saved if you so wish. So here you go. Then, especially if you want to share it with the stakeholder, then you show it. Looking at this, we can just base our argument. The accuracy score of 81 is at the k is equals to 20. And the accuracy score of 73 is at k equals to 2, or basically 1.25, half of that, or something like that. So at the end of the day, k equals to 20 has given us some good results there. So that's accurate. So we can say that k is equals to 20 is the value for k nearest neighbors that can be used to classify whether the customer is going to churn out or not. Yeah, so you use the 20 values. If you want to predict for, let's say, someone who did something, then it means we must use the 20 values around that person, and that one will be at 81%. So if you use, let's say, like 80%, you just use 17.5 values. That is at 80%, but we always want the best. So even if you continue uh, iterating, let's see what 50 has. Okay, tutapatana nayo mbele wakimaliza. So here the value of the best classifier was k values. Then you find the argument, the maximum of the arguments using numpy of the accuracy scores, and we did that and found out that it is 20. Now that we found out the best is 20, we can now train the final KNN classifier. I don't quite to train model. The only thing we did, we just wanted to find the best K. So we just fitted the model. So let's just train it. So KNN classifier and n neighbors is now using the best K, not random K. So the best K was 20. So when you fit that, it is done. So let us run this and see. So as you can see, we've increased the values. So at 50, the value may increase. You have to be very keen because as you can see, the value at 35 is lower than the value at 30. So even this 50 kidogo tu ikuwe nini zitoshane hapa. So we can still settle with 32. I can see that the value of 32 or 50 can produce the same result. But if we run 49, not even 50. Yeah, so you see why we say it is very, very, you need to ensure that you do this. So in Amanisha, if you continue, it keeps on reducing. And the accuracy can be at 80 something. I think you can also print the accuracy. So accuracy score. Mm, okay, it makes sense because 0.80 to 0.78, we just have 0.02 actually. So it makes lots of sense. So it's at 0.81332. So as you can see, accuracy is not, even if you increase the number of K, accuracy is not increasing, telling us something. if you increase the number of k, you are at a very high risk of over or underfitting. So when you got the highest accuracy with the first smallest value of k, remember even at 20, the highest accuracy with the smallest value of k was still 81. So there was no need of extending because the accuracy was not changing. So to reduce the risk of overfitting, the best thing to do is to stop at 21 that had been earlier proposed. I don't know if you are making some sense there. Yeah, you can, it can work well with the data that you are using to train it, but it will work poorly in production. So you will be like, where did we go wrong? So you went wrong by using you see it's still 81. So never do that. So just stick to this 80.9 even at 20. So you see the slight increase was just of 0.01. So we train the best model with the value of k. So when we train it, we do that for with x scale and y train class. Then we can now predict accurately. Then we now print the accuracy score for the best value of k is 0.8091. I said 80, an 80% thing is not that bad. Then the confusion matrix, yeah. This one tells how do you interpret this? The values which were in the zero class has been well predicted. So if someone was predicted not to churn out, that one has been well picked by our model. So the model was able to predict that the churning out was not going to happen. But again, if you look at the value of actual was 0 and predicted were 1, that is only 99. So the model has really tried. The model has really tried. When you look at predicted against predicted, actual was to be 1, predicted was to be 2 or 3, to be 1. 1 against 1 is 2 or 3. But alarming is 1 against 0. Actual were 1, but the model predicted that 170 guys will actually churn out. So you really have to be very careful with such models. So we need to hypertune so that this one is reduced to bare minimum. And that marks the end of classification. And you've now seen how it can be used and how you can actually hypertune the parameter. Is there any question up to that point? Hakuna model ingine utabuild ya KNN kama si hii classifier. It's just this. And actually this one has gone into details. Any question? So let's now consider the regressor. Please, I highly encourage you to use only the regressors that work best for regression. If you are, don't use KNN. This is just for learning purposes. And in fact, there are a ton of other things that you want to see next. We will see next, like the random forest, which can be used for regression. So for regressor, we prepare the data for regression. We want to predict the total charges. Remember, the only regression only works for continuous variable. So you cannot predict, you cannot say I'm predicting for churning out, yet you call it regression. That is classification. So continuous variable, so we are dropping churning out and also dropping total charges, because churning out cannot be used to predict total charges. How can you predict total charges for someone who has churned out? So the Y regression is the F total charges. So our main task is to predict the total charges against the other X values. You split the data set, you scale the features, you fit the model, and see. You implement the K nearest neighbor classifier. Again, just like we said, we calculate the mean MSE cost. This is like the variance. The MSE cost starts with an empty list, then using the K loop, just like we did for K values. We do the same thing here. Remember, when it comes to evaluating regression, we now don't use accuracy. We use the MSE score or R squared. So when we did that, we were able to now plot the value of the MSE score. Now, when it comes to MSE score, we should settle for the lowest MSE. Why should we? MSE is variance. Variance is like the distance between a point and the distance between the mean and the data point. I think I explained the MSE in regression. So it is always the distance. It's like it is treated in regression as a variance, and the variance is always the distance between a data point and the mean. So that means that for us to choose the best value for k, it must be the one that has the lowest MSE and now not the highest. Are using how the two differs now. So when we find the mean squared errors for k against the k values that we calculated up there, let's now see which one produces the lowest mean square error when we plot it. So when we did that, again 20, the value of k 20, the mean square error was below 0.6. So you settle for 20. But if there was one, let's say graph ilikuja ikagonga hapa chini ikarudi juu kidogo, ungechukua hiyo ya chini kabisa. So when we select the lowest MSE, best k is evaluated against lowest MSE. So it is 20. Then we train using the best k, and now you can predict predict and also calculate the R score. As you can see, the mean squared error is now that for the predictions, and also the R score is 89.46%, which is a very good value. So this one, if you are supposed to use it to predict total charges for a guy, then it's okay. We have been at 89% accurate. So hiyo 11% hata ikikataa inamaanisha for every 100 values 89 will be true. Not bad. So when you plot actual against predicted, and now this one shows you the line of the best fit, what do you realize? That as actual increases, predicted also increases, meaning our model actually tried its level best and predicted the best way, the correct way. It's a very good one. So during deploying, we shall deploy this way, but we will never deploy k-nearest neighbor regressor. So this is just for learning purposes. I just wanted to show you that you can also use k-nearest neighbor to regress. But you will see some models that we are going to encounter before us, like random forest and voting and cascading. They are the best to use when it comes to prediction, because these random forests brings together one or more models. But this k-nearest neighbor is just one. So, and you will see when you evaluate it against k-nearest neighbor, you will see that the accuracy is the R squared is actually going to be over 90 or higher. Yeah. So that marks the end of k-nearest neighbor classifier. I think it's always the easiest and the most straightforward classifier that you will ever encounter in models. Yeah. Mm-hmm. Well, the elbow method, I think, is in the support vector machine. You are going to encounter it in hapo mbele. The elbow method is used to evaluate, but yeah, it can be true, but wacha tufike hapo ndio tumefanya argument yangu. Yeah. But you're a very good student, so you are captured that very well. So you want to tell me the new teacher did not cover these? Jesus Christ. PK Safaricom upewe ubuild machine learning model ushindwe what no. 1014 still early kidogo, acha to introduce the decision tree. So actually what makes machine learning fun is because the name also suggests what is what the model entails. The decision tree basically involves making a decision. So you're going to just draw a tree until you arrive to the final decision. For example, I want to play football. So there are two possibilities. I'll play it or not play it. And these two possibilities will depend on maybe the weather condition, and if the weather condition is there is good, is there availability of the pitch. It did happen last thing. So the church, as youth leadership, we sat down and we wanted to host the football, the match. So the weather condition was favorable, but the pitch was not. So the first decision tree, the first parent was, is the weather condition favorable? Yes. So let's move to the next one. Is the pitch available? No. You will not play football in this pitch. So we must have look for another venue. So you see, that is what decision tree entails. It is basically like the name suggests. It's a flow chart, like supervised classification model, and a representation of various solutions that are available to solve a given problem based on the possible outcomes of related choices. It is used for classification and prediction. Like all supervised learning classification techniques, decision trees enable data professionals to make predictions about future events based on the information that is currently available. So you cannot just start making a prediction if you don't have the information first. The information was, is the weather favorable? Yes. Availability of pitch. Of course, the pitch must be available to play football. So, like in our case now, when you want to see if the customer will churn out, we also start looking the previous data. Did this customer, the customer that churned out before, did he start making phone calls to the customer care? Yes. And if he did that, what did he say to the customer care? Was he complaining about network outages? Yes. Phone call. Did it last 2 minutes? Yes. So you move on with that decision until you arrive at when after all these the customer made the decision to quit. You see. So we now have a new customer. And when we follow the same decision tree, we just conclude that this one is also likely to quit because Bitula Lifanya is the same thing that this guy has also done. Na tumemaliza decision tree, hakuna ingine. They just support like that. So it requires no assumption regarding the distribution of underlying data. You work with what is there, no assumption. Then they can handle collinearity easily, and it's the best that it can be used when the independent variables are collinear, like they're correlated, if that is. Then you can preparing data to train a decision tree can be much less complex process requiring little preprocessing, if any at all. Just to show what we did there. Disadvantages. They can be susceptible to overfitting. I think that's the most disadvantage that we can pick. Because what if we say we use the basis yes, yes, no, yes, until we arrive to the fact that the client quit or churned out. Alafu huyu amekaa na sisi. Amekaa, it did not turn out. So at the end of the day, what did we use to make our decision? So overfitting might happen. The model might get extremely good at predicting scene data. Hey, that is what I just explained. But as new data is introduced, it may not work nearly as well. So the structure of a decision tree, of decision trees. So a decision tree consists of nodes and edges. So when we talk about nodes and edges, the point. Machine learning is fun. So this is what is called edge. This is what is called edge. You have another one. You have another one. and this is what is called node. So we can still, for example, so this is the parent node where the decision starts. So is it raining? Okay, with football you can play, but with for volleyball, is it raining? Yes, no. So can't play volleyball. Okay, is the rain stormy or calm? Stormy, can't play volleyball. Okay. No, yes. So you can still go with the yes. Stormy, calm. So when it's stormy, you can't play football. With no, play directly play football. So acha nianze ndio ionekane vizuri. So we have the parent node. Is it raining? Yes. No. Is it the rain stormy or is it calm? Is it raining with storms? When it with storms, no, you can't play football. Otherwise, calm, we can. No, play football. Or even if it's no, uh, scorching sun or humid. So if it's humid, play football. Jameni, isn't it straightforward? So that is actually what decision tree entails. Decisions are made at each node, and that's exactly what we did here. Then at each, a single feature of the data is considered and decided on. By the end, any relevant features will have been resolved, resulting in the classification or prediction. Root node or the parent node, the decision node, then we have the leaf node down there. The golden node is the leaf node. Consider the decision tree below. It is a decision tree that will help you decide whether or not to go outside and play soccer or football on any given day. I think you have done this, so there's no need of repeating. Further decision making process, the whole process ends there, so no further decisions are required after this point. Now, view where the decision tree would have gone if the outlook had been sunny. Why it not a leaf node yet? So when you've not yet arrived at a leaf node, you still call that a decision node. If it is humid, the humidity is above 75, the tree ends at a leaf node that says don't play soccer. However, if it is below 75, you will play soccer. So it means that we could have still gone on with our decision tree if we so wished. Is it 75 or less? Play soccer not. Unaona? So sisi tumemaliza hapo kwa leaf node, but you can actually have, at the end of the day, you can actually have something that is so long like this. So leaf node becomes here, and the decision nodes can even be at, then the root node or the parent node is there. Yes, this one was coded by someone at SKLang. To answer your question. So, for example, if 90% of the time that it rains, soccer is not played, this variable will be very predictive. Splitting the data on Outlook will give new groups, each of which has a majority of play and don't play. Now, you know the basics of decision trees. This foundation will be helpful as you continue learning about decision tree modeling, tree-based modeling. In a chart, there you go. Outlook, sunny, cloudy, rainy. When it is cloudy, tushafika kwa leaf node, play football. But when it's sunny, is it sunny with humid? Negative 7, less than 75 for greater than. When greater than, don't play. When less than, play. Is it rainy? Like there is wind when raining. True or false. So you just make your decision based on the outlook. Hyperparameter tuning is the process of adjusting the hyperparameters to build a model. Do I need to explain that really? You've been doing that most of the time. And the main aim is to prevent overfitting and underfitting. Overfitting is when the model learns the training data so closely and accurately that it captures more than the intrinsic patterns of all such data distributions. That English is too much. And ends up learning noise of idiosyncrasies. Ay, did I just type that? Okay, in short, it works best in your training data and performs poorly in the unseen or the main data that is incoming. But our main target is always to ensure that we monitor how, like, the incoming data, we monitor and see how is it going to work with the incoming data. So tuko tu hapo tunaangalia. So it should work best. And that's why to build machine learning model for market share, we just need it first of all to ensure that people purchase on our platforms and we keep this data and use it to build the model. Because this one will be real world scenario. Okay, then underfitting is when the model does not learn the patterns. Okay, this one is you will wait for it to happen. Ati it does not work well in your training environment, then works well in production environment. Ulisikia wapi? But okay, we can't rule out the fact that it might happen, but it is close to impossible. Don't want to lie. So why should we do tuning? So far, you've learned about modeling techniques to make predictions or better understand data. Sometimes the models perform well right out of the box using the basic or default application of the underlying theory. But most often, however, this is not the case. Each data set presents its own set of characteristics for which the data professional must tailor the model. Nasikia hiyo maneno? So depending on the characteristics of the data, both the data and the algorithm used to model it, a model might overfit or underfit the data. So remember, the aim of predictive model is to identify underlying intrinsic patterns and characteristics in the data that are representative of all distributions and use these characteristics to make predictions on new data. So we tune so as to find the best one that will work with the new data that is oncoming. Which means we are not just going to stop at you build the first model, look at deploy work. You are like, now I'm okay. No, 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 no. You must monitor it and ensure that it works well as intended. And if it is not, you retune again. And that's why you are paid a monthly salary. So what are these parameters? Hyperparameters are aspects of a model that you set before the model is trained. I love this definition. Look at what we did here. Before we train the model, you see we said select best K, then train final KNNS classifier. So we set the hyperparameter first here, here, with the hyperparameter tuning. Then so actually we did practical before reading theory. So it is actually very easy to understand. So the hyperparameters for decision trees, maximum depth. You can guess the maximum depth the tree will construct before stopping. That is from root node to the leaf. How many decisions do we have? How many decision nodes do we have in between? That's the maximum depth. Then the minimum sample split. See, we are splitting. The minimum number of samples that a node must have to split into more nodes. Yes, so hapa to split, like up there, I've seen them splitting 3 times. Then minimum samples leave. The minimum number of samples that must be in each child node for the split to complete. So let's go back and revisit. Here we go. So maximum depth is only from, in this case we have 3 maximum depth, actually 3, yeah, from the root node, the decision node and the leaf node. Then the minimum sample split. The minimum sample split is how many samples should the outlook have for us to split this into 3. So that one should be considered. And please ensure you use the default. So when we go back to our Kenya's neighbor classifier SK learn, we just come here and search for decision tree and read the arguments. Oh, thank you. Here we go. And remember, they are non-parametric supervised learning method used for classification and regression. And the goal is to create a model that predicts the value of a target variable. So let's look at classification, decision tree classifier, and the following are the arguments. Minimum sample, the maximum depth integer default is none, so it doesn't have maximum depth. So the maximum depth of the tree, if none, the nodes are expanded until all leaves are pure or until all leaves contain less than minimum sample split sample. That is to say, until we reach the ground level decision. We also have minimum sample split. The minimum samples of split required to split an internal node. So the default is 2. That is to say, let us just be realistic and honest. Hey, sometimes it's good to be realistic and honest. So the outlook, you want to split it. Why should you split it if you're just going to use play alone? One, cloudy play, you are done. So the model is saying that the minimum sample split should be at least 2. So you should, in short, you should at least have two bases of arguments. Then the minimum samples leave default is equal to 1. The minimum number of samples required to be at a leaf node. A split point at any depth will only be considered if it leaves at least minimum samples, if training samples in each of the left and right branches. That is to say, the minimum number of okay, ni samples. So I don't know how to explain. I cannot use a word that is not befitting. The minimum number of samples that is required to be at the leaf node. So you are required to have at least one basis of decision at the leaf node. So, for example, in the leaf node, we had to play or don't play. So at least one. So the maximum depth 0, depth 1, depth 2, as you can see there. The root node is of course depth 0 because we've not started the decision, the making decision. The minimum sample split is the minimum number of samples that a node must have for it to split into more nodes. For example, if you set this to 10, then any node that contains 9 or fewer samples will automatically become a leaf node. So it will not continue splitting. However, if the node contains 10 or more samples, it will continue splitting into child nodes. And the greater the value used for minimum sample, the sooner the tree will stop growing. But remember, you can just put your minimum sample split. At the end of the day, itakuramba na one thing, overfitting and underfitting. It's just waiting for you at the corner. You want to put minimum sample split, just put, I'm waiting for you here. If you have some time, learn more and more by your link. Aya, we shall look at support vector machine. Sitaki kuiguzia sahi. Let me jump to, because we shall actually ensemble learning. Ensemble learning, acha nisikoroge akili. But ensemble learning is basically bringing together 2 or more models to work with. So we stop there. Tomorrow we shall start with the theoretical approach to support vector machine, then build the decision tree model, then support vector machine model. Support vector machine is my best classifier. I love it. I don't know why. Because maybe it was the first one I built for Texavan and it worked well, and we integrated it into a flight management system. So and it worked perfectly. So at the end of the day, I just found myself loving it. And maybe because I did more research before building it, I watched YouTube videos, I built the model, a mock one, tried to deploy, then after that, now worked with the team to deploy it in production, and Yes, there you go. So there you go. I hope you are learning. You are actually enjoying the course, and that's my main my main thing. I want you to enjoy the course so that when we are done, ukipewa assignment, and I will be able to see that your machine learning model is online and live. Then we have to just be, yeah. I did a very fantastic job with the students.